Hey there. This is chapter 6, day 6, AP Stats. And we are going to go through kind of a review activity. And this is going to be, if you're looking to study for the quiz, this would be kind of a good sample dry run for you. This would be good for you. Okay. So let's look at these questions if we can. Um, let's see here. So the first one, move this. Okay. So the first one, um, we got Fat Fap sells T-shirts at lunch for the Nerd Club. He always sells 1, 2, 3, 4, or 5 shirts, as you can see right there. And the probability of selling those shirts is this respectively. So the first thing is make a probability distribution table. No problem. This table's really easy. So just go ahead and pause the video and write this down. Very simple to do. I got to make it a table there. There we go. Right there. Okay. Now, this one, find the probability that he sells more than 3 shirts. I did not put context, but that's what it is. More than 3 shirts is pretty obvious. It's obviously 4 or 5. So it's just 0.2 plus 0.2 is 0.4. No problem. Number 3, find the expected number of shirts. The expected is when you multiply, and this is the formula for that, okay? So 1 times 0.2 plus 2 times 0.3, etc. That's also called the mean of the distribution. Okay, so the mean is 2.9. Obviously, he'll never sell 2.9 at lunch, but it is the average number he'll sell. Remember, you can have an average that's not a number that can happen individually, like the average number of children in America per family is like 2.3 or something like that. And of course, nobody can have a 0.3 kid, but it's the average. Okay. Kobe Bryant can average 25.2 points a game, but he'll never score 25.2 in a game. You get the idea. All right. And then the meaning of this, if they ask you for the meaning of this, you would say the average number of shirts FAP will sell in a day is 2.9. Pretty simple. Now, the standard deviation is that giant square root, okay? You take every number and subtract the mean and square it and multiply it by how likely that is. So you can see the arrows is the probabilities. The underline is every individual number minus the mean squared, okay? This formula is actually consistent with the original standard deviation formula. It's just a hybrid of it, much like in trigonometry, you have sine squared plus cosine squared is 1, and you have all the hybrids that go off of that. So, and there's this. So that ends up being about 1.45 or so. Now, if they ask you for the meaning of this, the meaning of this is the typical deviation from the mean is about 1.44 shirts. Okay, so that's pretty simple. Now, number 5 is the median of the distribution. The median is the 50th and 51st percentile averaged. Now, in this case, it's kind of interesting because if you add these 0.2 and 0.3, these two that I'm circling, that makes 0.5. So if this was in percentiles, the 50th percentile would be a 2, and the 51st percentile would be a 3. So the average is actually the 5th and 6th values added up out of 10 values, which is 2.5. Now, most of the time, it doesn't work that way. Usually, it's just one of the numbers. It happens to be a number that's not in the table because only 1 through 5 are in the table. But so the median is not a number in the table. That can actually happen. Okay. So there is that. Okay. Erase all this. Okay. Good. Easy. There we go. Okay. And then let me scroll down a little bit. Now, for questions 6 and 7, here's a table that's drawn. All right. So what we got here is the first question is find the probability that x is between 2 and 4. Between 2 and 4 is this shaded area right here. And if you just count the boxes, there's 10 boxes, and 20% of the boxes is that. Now, this is a distribution that's skewed right, but it's a very unusual distribution. It's not a normal curve. It's really strange. So you just kind of have to find the area of it just using old school math. Now, number 7 is a trick question. Find the probability that x is exactly 4. You don't have any value at one particular point when you have a distribution that's drawn like this in a curve. You need 2 points for an area. So anyhow, I kind of wrote that out. There's no value associated with any one particular point in a continuous curve, okay? The most common continuous curve is a normal curve. So there you go on that. Okay, so that's pretty easy, okay? Then let's see. The next thing we're going to do is number 8, okay? The average height or weight of a La Quinta football player is 195 with a standard deviation of 20. What is the probability that a 250-pound linebacker is at the school? Assume a normal curve. Okay, so you're gonna. This is from chapter 2. You've got to know this. You're gonna draw that curve, and this is stop the video and draw it out. Okay. Remember, it's raw score, z-score, and percentile. Okay. And then the raw score is 195. I mean, that's the mean. Okay. And then the standard deviation is 20 right there. Okay. And you're finding 250. That is way out here. I'm going to shade it. It's not much. 250 is not super common. Okay. There's 250 right there. Okay. So what do we got here? Okay, you're going to find the z-score of that. Here is that z-score formula. Do you remember that? The number minus the mean divided by the standard deviation. No problem. It comes out 2.75, very deep in the tail. And then on your calculator, which is probably how you're going to do it, you're going to go NCDF. This number right here is infinity. I put 1,000, but that represents infinity. Here, all the way to the right. And it comes out, it's really unlikely. It's way less than 1% chance of that happening. Okay. All right. So there is that. Now we're going to go to the next problem, which is, erase all this. Okay. So the next one is about rolling a pair of dice. Okay. So if you roll a pair of dice, the chances you get an 8 or more. If you remember dice, the most common roll is a 7, and the least common roll is a 2 or 12. So, and this is the probabilities of it. We did this, way back, well, not way back, but in chapter 6. Okay. So 8 or more is just right here. So the first thing you got to do is get the whole sample space, and then just go ahead and add those up, and you get 15 out of 36. Pretty simple. Okay. So that's an easy question. Number 10, if you roll 1 die, now it's just 1 die. Now here is the probabilities on 1 die. Here's the table. It's pretty obvious on 1 die. Okay. Probability of you getting a 1, 2, 3, 4, 5, or 6 is 1/6 of the time. But here's the payout on this. If you get a 1 or a 2, you get a couple of bucks. If you get a 3 or 4, you get 5. If you get a 5 or 6, you get 10. What is the payout? Payout is the same thing as the mean. It's the same thing as expected value. So you might want to write that out. Mean, expected value, and payout are all the same. So how do you do that? You're going to multiply $2, the money part of it right here, times the probability of you getting a 1, which is 1/6 right here. Then you're going to add that to $2 for getting a 2, which is 1/6. Then you're going to add probability of getting a 3, which is a $5 payout, a 4, which is a $5 payout, and then a 5, and then a 6. It works the exact same way as expected value, but just put the dollar amounts. And so the payout is $5.67. Now you may be asked, what does that mean? This means that this game pays out on average $5.67 every time you play. Now, in number 11, if it cost you $7 to play, is the game fair? Well, no, it's not, because if you pay $7 to play and you pay out $5.67, then you actually lose $1.33 each time you play on average. Okay, and of course, this is the kind of game that Vegas likes because they're obviously looking to make money over time. Okay, so there's payout. Payout's the same as mean and expected value. All right, so that's cool. Okay, so let's go to we're going to go down to number 12 through 14 in a second. And these ones will require quite a bit of probably stopping the video, etc. Okay, so let me get down to those. So for 11 through 14, hopefully you got it on your notes there. Okay, so or 12 through 14. Okay. For this question, let's see here. Okay, Huey and Louie, so H and L want to qualify for a bowling tournament. Huey averages 213 with a standard deviation of 15. Let me circle those. While Louie averages 210, standard deviation of 20. All right, so we got 3 chances. These are really classic problems. They both need to bowl a 225 in their next game to qualify. What's the likelihood of each happening? All right. So for both of them, you're going to draw that normal curve. So let me draw that down here. Okay. So for Huey, for H, okay, his average is 213, 213, and his standard deviation is 15. Okay. And we've got to figure out the probability of getting 225 or greater. 225 or greater, okay? And again, we're going raw score, z-score, percentile. There's the raw score. The z-score is right here, right there. There's the z-score, okay? Take 225, subtract the mean, divide by standard deviation. It's 0.8. So 0.8 is actually right in here about, okay? So it's a pretty good shaded area. I mean, I can even shade that maybe better. Well, that's fine. And then you're going to do the z-score. So it's going to be NCDF. Remember on your calculator? You're going to put in 0.8, comma, infinity. You're going to write probably 1,000 for that. And that's going to come out 0.2119. Okay? For Louis, it's a little bit different. So for person L, I'll write that over here. Okay, again, raw score, z-score, and percentile. He averages 210. And his standard deviation is 20. So he's a little less consistent. It's still normally distributed, okay? So we're going to get and again, he still needs a 225. So 225. And we're going to shade that area, okay? That z-score is 0.75, a little smaller, okay? Which actually leaves more room in the tail. And then once you get that, again, that's the number 225, so 225 minus 210 divided by 20. And this is going to be NCDF 0.75, comma, infinity. And again, probably put the number 1,000 in for infinity. And you're going to get this number, 0.2266. Okay? So there's those two. Okay, get rid of all this again. Okay. Now, next question. Next question. These are classics. This is what are the chances that they can qualify together for the team competition? They need 450 to do this. All right. So this is where you got to combine the curves. Okay. So clearly combined, these guys will average combined 423. Now, how did I get that? I simply added 213 and 210. So 423 is their combined average. Their standard deviation is Pythagorean. That is right here. You take both standard deviations, you square them, you add them, and you re-square root them. This happens to be a 3, 4, 5 triangle. So the standard deviation combined is 25. Once you have that, it's just a regular problem. You got to identify what you're looking for, and they need over 450. So let's go ahead and put 450s right about here, 450, and then execute a z-score for 450. And that z-score will be right here, okay? It's the number 450 minus 423, the mean, divided by standard deviation. So that z-score is 1.08. And then you want the area to the right of it. It's around 16%, close in there. So it's right here, but you're going to go NCDF, and you're going to go 1.08 comma infinity, and the infinity number, just type in 1,000 on your calculator, and your answer is about 14%, 0.1401. Okay. All right, last one, and this is the one that is usually hardest for kids. They just kind of forget. It's not any harder than the other one. There's just a couple of steps, that some logic you have to apply that maybe can elude you if you don't concentrate. What are the chances that Louis beats Huey? L beats H. All right, so what you do is, this is the head-to-head one, head-to-head competition. You have to figure out who typically wins and by how much. So who typically wins would be Huey by 3. So I'm always going to make this a positive number. Simply write the difference between them. It is 3. 213 minus 210. The standard deviation remains 25. It's still Pythagorean. You still do this right here that I've circled. You don't subtract it because it's a subtraction problem. You just simply combine it. Okay. Now, just label 0 to the left of the number. Let's label it. 0 is where they tie. Now, what I like to do is, you got two sides, the left of 0 and the right of 0. I like to label it by simply who is better. And in bowling, high score wins. So Huey, or H, averages 213. Louis, or L, averages 210. So the right side is going to be H, because he's better and will win more often. The left side of 0 will be L, because he has the lower average score and will lose more often. Now, the question is, what are the chances that Louis wins? Louis is the weaker player, so we want this area right here that's shaded L. Okay, we want this smaller area right here. No problem. So that z-score is going to be right here. Okay, that's 0 minus 3 divided by 25. And that z-score comes out negative 0.12. And now we need the lower side, and that's going to be NCDF. Now we want the lower side of the curve. So you're going to type in negative infinity into your calculator, which is going to be negative 1,000. And then you're going to type in the z-score, negative 0.12. This is all from chapter 2. And you're going to get this answer right there, about 45%. Okay. I should have moved it over. It's probably right about there. That's a little bit better drawing of that. Okay. It's a very small z-score. So very, very small negative anyways. Okay. So this is what I would study for your quiz. And that should come up the next day, and good luck to you. Statman out.